So today we're talking about building a secure Kubernetes service for private cloud, mainly led by Fintan from BT. So it's more talking around experiences as well as decisions about building a platform to be able to support not just telco-focused workloads, but also generic, cloud-native workloads as well. So I'm Nelson. I'm a cloud-native specialist at SUSE. So I mainly focus on our UK market, but I cover everything from marketing, partners, and also end user, where I'm also helping design cloud-native strategies for customers, whether it be in telco, finance, or any other vertical in the UK. So I'm joined by Fintan.
So I'm kind of doing like delivery and product management of this like Kubernetes service we've built on our telco cloud in BT. So I work in a team of like our principal engineers. We've got principal platform architect and who kind of oversees all this across multiple different clouds, as you'll kind of see as we go through this. So yeah, we'll jump in. So a few things we're going to cover today. So there's kind of three main things. It's to show how we actually rely on Kubernetes. This is more applicable when I present this in the UK because then a lot of people are actually on the exact cloud that I'm talking about. But even here, it's how the mobile network is actually running on Kubernetes. Kind of what the current landscape looks like in cloud native telco, like where we're at in that journey, because that's kind of forced us to make some decisions on how we're doing things at the moment. And then what we're building with Rancher and why it's been tricky to drive adoption of that platform and sort of where we're at in that journey. So a quick little intro to BT Group and what we do. So we're the biggest telco in the UK, do kind of everything a telco does, fixed networks, TV and broadcast, mobile networks, a load of other, all that stuff for business as well. A lot of fixed line stuff, a lot of custom solutions for businesses, private networks, and sort of I work specifically on our on-premise cloud team running, we call it Network Cloud, and it's the cloud that runs most notably the 5G packet core. It's probably the workload that gets us talked about most in the press, and we have been, not that I can take credit for many of these years, but for 11 years in a row, the best mobile network, or EE, which is BT's brand for the mobile network, has been the best mobile network in the UK. So we are under a lot of pressure every year to not be the one who drops a year on that one. So where do we sit? For who here is like telco based? Show of hands. Okay, so we probably don't need to go through this in loads of detail, but quick idea of sort of what we're talking about here, what part of the telco network. We've got, you can see it going through here from the radio access network to the RAN convergence, metro network, mobile core, and then kind of out to your internet, CDNs, whatever it is you're trying to get to. The bit I'm talking about here is that bit in the blue circle. It's the converged core. It's where the voice and data runs the messaging platforms to 4G and 5G and still 3G at the moment. And any other number of like API gateway services or whatever it is that's running on our cloud. So to kind of start off on, explaining why we're here, I'm going to run through like how we got to this point. So it's a bit of a history of the kind of network function stuff. So, physical network functions are, that was what was around before I joined BT. I don't have much experience with PNFs. But vendors are selling dedicated boxes, dedicated hardware for specific functions. It's expensive. You're pretty locked in. There's not much interoperation going on, and they are black boxes. And kind of in from a security posture point of view, it's not ideal. We've then seen, and this is still primarily, I'd say, what I work on the most at the moment is the virtualized network functions across our virtual environments. So a lot of that has been just lifting and shifting PNFs into VMs, but being able to place them on commodity hardware so we can build out common cloud capabilities. And that's what we've been working on, and we've been placing a lot of virtualized network functions on our OpenStack cloud at the moment. Where we are going, or we are told we're going, is towards containerized network functions, with all the benefits of containerization with the microservices architecture, things that are abstracted away from the substrate. They are agnostic of what they're deployed on. But I think that the reality of where we are at the moment in this journey is actually in between VNF and CNF. We've had examples even of being offered containerized deployments, going so far as to deploy those, and they are being reverted back, and we're being given virtualized network functions again because of certain issues. And generally, I think it's just complexity because vendors don't want to completely re-architect applications to offer us containerized network functions. But the other thing that, with containerized network functions that we're seeing is with vendors who want to ensure that their containerized stacks work properly, they're selling us full stacks. They want to sell you the hardware, they want to sell you the virtualization layer, they want to sell you the orchestration layer, and they want to sell you the application. And actually, if you think about that, it's basically taking a big step back to go into PNFs because they want to sell us everything. So, some of the things there, like what we're trying to, where I'm going with this is what we're trying to kind of push back against with starting to build a Kubernetes platform in-house. It's that sprawl of Kubernetes distributions, which we find quite hard to manage. It's interoperation of different components in the network, because if we have a vendor-provided stack on a vendor-provided Kubernetes, it's pretty hard for us to operate that with anything else. And it's also the risk of the increasing TCO as we go and deploy like fully vendor-provided stacks. So, a quick view over like what exists. So this is like before we started building anything with Rancher or anything Kubernetes based of our own. This is what was there. This platform has been around for around 5 years now. It was built to move away from a fully vendor provided stack, and like because of government regulations saying that we had to do that in the UK. What I've got on here is like there's kind of two broad types of site that we have. They're slightly different. So we've got our management clouds and our NFVI clouds. They are both OpenStack clouds. Kind of from the bottom up, they are both with commodity compute servers. We orchestrate those servers with MAS, which is essentially a Pixie boot as a service to orchestrate the metal in those. And then we use OpenStack, and we have, there's two main types. The management clouds are kind of our more simple ones, generally single interface, VMs running everywhere. They are with Open Virtual Switch and a Juniper switch fabric at the moment. And then the NFVA clouds kind of for the more complex, the user plane, control plane functions, and they are with OVS and OVN SDN, and again, Juniper switch fabric. And I suppose just to, I think most people here are telco, so I'm probably kind of preaching to the converted here, but it's, on our NFVI clouds, we have two main types. We've got control plane and we've got user plane. We generally segregate the workloads because of the different types of requirements for performance, latency, etc. So, we're looking at kind of for the control plane applications, like a few megabits per second. And for user plane applications, you're talking like gigabits per second. So, we've obviously had to, it's been good when we're building the Kubernetes platform because we've had a lot to refer to and look at with what's been done in the OpenStack cloud so far. So the scale of this is like, we got about 7,500 physical servers, 50 plus instances, that's like 50 plus separate OpenStack clouds across like dev, test, pre-prod, prod. And we're, like all telcos are, this has got to be 5 nines. And actually, so just on the like right-hand side or left-hand side, as you look at it with the kind of core platform things, that observability and identity and everything. At the moment, that just extends into the OpenStack layer. So as a platform team, we manage everything up to OpenStack. It's an IaaS model. Tenants bring their own VMs, they bring their own images, and they go and deploy whatever they need to on top of that. There is a lot of Kubernetes running on this platform, and just none of it's managed by the platform team. So a quick touch on like regulation and again, why we've built stuff the way we have. So in the UK, we've got something called the Telecommunications Security Act. If we don't comply with this, it is fines of up to 10% of turnover, which for BT is hundreds of millions. So it's pretty significant. And I think like this is why you'll see sort of throughout, but the segregation requirements, the kind of dedicated host requirements, things being self-sufficient, things needing to be monitored and logged in the way they are, kind of I will touch on this again as we go and sort of explain how we're meeting those segregation requirements. So back to sort of a similar diagram to before, and I'm going to sort of demonstrate what we're actually building. So we are kind of taking the OpenStack clouds again. We're starting to deploy like a CAS service on top of that. So we have a piece of that we own as a platform team. We call it CAS management. Essentially, that's where we put the Rancher. That's where we put any of the logging and monitoring tools. We deploy some of our own kind of platform clusters where we will run common tooling. The important thing is actually that alongside this, we're not changing the core function. It's done through tenant segregation. Tenants get their own host aggregates. They get their own projects. They can still have VMs running on the platform, but they can also now have a CAS service running alongside those VMs. So they have freedom of choice. And if they're bringing a containerized application, they can come and request a CAS platform from us. So that's in the management clouds and the OpenStack stuff. We are also offering a bare metal CAS service, which again in this instance is tagged onto the same switch fabric and with the Rancher still built on the OpenStack cloud. So again, it's a way to sort of utilize what we've got, what's existing and what works, and start offering out more capabilities to our tenants. And then it's a similar thing there across the NFVI sites on this side with VMs and CAS stuff running side by side. I think, and then we, with the observability and the identity and access piece and the monitoring, we are bringing that up now into the CAS layer. So we're starting to get a lot more visibility of tenant workloads, and it's enabling us to, ultimately we want to deal with that is we want to streamline operations. We want to bring more control over the platform to the platform team, but still give tenants the ability to configure what they need. I suppose to answer a question of why have we built this, it's, like I said already, the OpenStack cloud existed, and this is where the majority of the 5G packet core runs already on a vendor-provided Kubernetes. So, and there are also other virtualization and Kubernetes platforms running within BT. There are a lot of them. So what we didn't want to do here was go and try and build something else and go out on our own and go and build a KubeVirt stack or whatever that would be and say, because then we're just trying to solve a problem by going N+1 and building another new platform and then having gain everyone's trust with that. It was, okay, well, let's take what we've got with OpenStack, take what's known, what's trusted internally, and go and see how we can kind of provision a Rancher service on that. And in that way, I suppose it's a step in a journey, but we're still serving the needs of a lot of tenants who, even just in recent months, we've had a lot of people coming along with requests for, somewhere to host a containerized workload. Nelson, do you want to?
Yes. So I just wanted to chime in because Fintan mentioned a really good point around the original OpenStack cloud, and that was that it was already running Kubernetes workloads in the first place, right? Unregulated, people who are hosting, and it's all good and working. But when you're building a product, to be able to offer services towards your tenants, i.e., like a containerized service, you are there because you want to be able to lead adoption and be able to meet the right requirements of your customers. So obviously, Fintan mentioned around, why did they choose to use the original OpenStack cloud rather than building a brand new one, shiny and new, bare metal, using all the new fancy technology like KubeVirt and all those kinds of pieces on there, is because they obviously needed to be able to build a platform that still served the existing users, was familiar, to be able to lead adoption, for them to be able to then build maybe a dedicated CAS platform later on down the line. Because anyone who is building a product needs to be able to prove adoption first before they can build investment later on, to be able to dedicate time, effort, and actually introduce components for dedicated containerization and cloud-native workloads.
Cool. So a bit more detail on what we've actually built here. So this is an example of kind of a telco CAS deployment, what we're calling telco CAS deployed on our NFVI sites. So important things to note, this is across what's shown on the screen there is across 2 physical sites, so across 2 separate OpenStack clouds with the management components. So Rancher and in this case Harbor deployed on a platform project in our management sites, and projects in this sense are OpenStack projects. And then there are 2 projects on the NFVI side. So there's a control plane project, which is managed and run by the platform team, by my team. And there is a tenant workload project, which is what the tenant sees. So the idea here, before I go into some more detail on the kind of component sets, is that we're trying to take away as much complexity as we can from the tenants about managing and running Kubernetes infrastructure, but trying to give them a experience that's as close as possible to like the IaaS service, which they know from OpenStack. So they still have the ability, like for example here, they still have the ability to go and deploy. They pick what OpenStack flavors they use, and they go and request the host aggregates and the space in which they deploy those. So it's trying to kind of fit into that model which has worked in the tenant segregation model, which already works on OpenStack, and give them the ability to put a containerized workload there. So like on component choices here, we've got Calico as our CNI in the cluster. We chose Calico because it works. It's a pretty standard deployment of Calico at the moment. We're then using Multus as a CNI plugin to expose multiple interfaces from pods. So we've got a bit of that running, and there's some more detail on that as we go on. In terms of storage, we're using the Cinder CSI. Again, we've got on the OpenStack cloud, there's Cinder storage backed by Ceph clusters and backed by some physical flash devices as well. And yeah, I suppose the thing to note here is that tenant VRF across the bottom that's a big part of how we're doing the tenant segregation here. So each tenant is sitting on a dedicated tenant VRF. So there are, whilst these projects actually will all sit on different VLANs, they're unified by an L3 tenant VRF across all the, which actually brings the clusters together and allows them to interoperate. A key point is as well, we don't do stretch clusters, so the control plane and workload project will always coexist in the same site. And then we've also got in the platform project where that's where we run the logging and monitoring tooling and observability. So we just kind of use the Rancher logging and monitoring tools like Prometheus, Grafana, Alert Manager. There's Node Exporter in there for the Linux VMs, and then there's some Fluent bit as well for logging up to our federated observability stack. So again, it's trying to integrate it all with existing open source stacks that we've got for observability as well. So we're kind of offering for the workloads here 2, if you include the single interface one in the management stack, 3 solutions. And this again comes back to the requirement to differentiate between control plane and user plane applications, and a kind of standard implementation here with Mac VLAN and with Multus, and then there's also an SRIOV implementation. But I suppose what the advantage we've had here with Rancher is that we can deploy Multus-enabled clusters from Rancher. I'll get into how we do that deployment in a few slides time, but Rancher enables us to do that. I think it's with a Multus daemon set. And we can just have Multus-enabled clusters there using the Rancher Terraform providers to deploy that. And then we're also trying, in a similar vein to the kind of IaaS points I touched on before, to give tenants the ability with a network attachment definition for Multus to configure their own host pools, or their own IP pools, so that we don't have to go and set up all that stuff for them. So it's kind of that slight difference between a CAS or a PaaS service and an IaaS service, where they get a cluster, but we want to give them the ability to then go and populate that network attachment definition themselves, so they can decide what they want to do with it. So with the Mac VLAN approach, it's a pretty standard Mac VLAN approach. It relies on the host CPU to do the processing. It's operating on layer 2, and it's pretty efficient for multi-interface pods. It's been pretty good for the control plane applications that we've used it on already. But as we move into the user plane, there's a desire obviously for higher performance, and that's where we've got SRIOV. Again, it was quite nice because we had SRIOV VMs running already there. We could go in and have a look at what was going on in those and see how we could do it, and see what performance we should expect from it. But we've got, for anyone who I suppose isn't familiar with SRIOV, basically what it enables us to do is break an SRIOV enabled NIC, in this case an Intel E810, up into multiple VFs. and then present that VF via Multus and the SRIOV plugin, SRIOV CNI plugin, to the pod. So the pod on its secondary interface essentially has a NIC of its own, a physical NIC of its own. And that is what enables the high performance, because you're then essentially routing the packet directly onto the network, and you're doing packet processing in the NIC and not using the host CPU. It's also got good advantages for isolation, and because again, that NIC, it can then be, the packet, the host path can then go straight to whatever, leaf switch or wherever you want it to go. And we've had some recently also set up a STTP configuration with SRIOV, because then you can tag it to specific leafs and have like a red-green, highly available traffic path for user plane applications as well. So how do we do the ingress and egress? So this is on the Mac VLAN enabled pods, the Mac VLAN enabled nodes and pods. So at the moment, we're doing it in this way with a combination of MetalLB and with Nginx ingress. Again, because these are things which are kind of well known, we've done them on the management side of things beforehand. Basically, you've got a MetalLB VIP, which goes into an Nginx ingress controller running as a daemon set, and then that ingress controller then sends traffic to your pods. This works. It does actually work pretty well, but it's not super performant. And actually, as you can imagine, as we scale up with this, we've started to struggle with the kind of management of the IP address space, because we push some of it off to the tenant, the network attachment definition for Multus, but then giving the tenant the keys to manage their own MetalLB space has been a bit tricky with the kind of platform tenancy crossover. So yeah, we've got this in a few places, but we're kind of looking at what else we can do. So the sort of next step for us was to look at external load balancers. This isn't running anywhere in production at the moment, because we're kind of in early days, and obviously there are some commercially available external load balancers. LoxyLB is an open source load balancer. I was interested, has anyone heard of it or used it before? So it's an eBPF based load balancer, and I think what we're looking at here, on the benefits of kind of deploying a containerized load balancer first, we've got the ability here to have a load balancer with eBPF, which can operate L4 or L7. So with that, you can cover off your firewall requirements. You can potentially cover off your ingress controller requirements. You can cover off your load balancing requirements, and even possibly with the load balancer, cover off your multi-homing requirements if you're up for doing it that way. And it's just that way of trying, like I said, this project isn't about necessarily finding the end goal in this current configuration with everything on OpenStack, but it's looking at, okay, let's see how we can progress this towards, moving stuff onto containerized deployments. And the load balancing one is funny because I think this very quickly becomes like application level things that where do you draw the line as a platform team, as to, you go and start configuring load balancers and testing them. And so, it's been a bit of a collaboration. I think that was it on that one. So back to so we got a couple of other kind of like product offerings. So I kind of went through this one, the telco CAS offering, again, standard. There's a, I suppose, thing to note, actually, which I didn't mention before. This is a Rancher per tenant, so there's no multi-tenancy across clusters or multi-tenancy. In the NFVI, there's not even multi-tenancy like across physical hosts, because we do CPU pinning and dedicated hosts for those like network function virtualization applications, just because of the criticality and also because of the TSA requirements requiring us to do so. What we do in our management clouds is it's a very similar thing, to be honest. This is where we run, there's element managers running here, there's like data analysis applications running here. And it's essentially the same core components. It's single interface, it's more simple. We don't use Multus, but it's still using Calico. Again, it's still tenant segregated, so tenants are still getting a dedicated rancher. But it's the requirement here and the reason we don't run that on the same clouds, it comes back to the segregation requirements. So the kind of way it's been broken up in the UK is that anything which is a network oversight function, so like an element manager or a data system required to keep your telco cloud compliant, that needs to be separate from your enterprise IT, but it also needs to be separate from your telco core functions. So this is where we've got these kind of management clouds, or the domain separation between the three clouds. So again, it's been what we can do though is still offer. What we're trying to do is offer that common journey for our mobile tenants to land on the same thing in that management domain versus in that telco domain, and not try and like I said, build N+1 platforms, do something different for a specific domain. Let's try and make it a common offering across all, just both of these domains. So we've also got some bare metal clusters running. This kind of came out of a requirement to run some big like data processing, data ingest applications, which required a lot of local storage. We've done this by utilizing the same like platform stuff we've done. So putting a Rancher, putting a Harbor in a project, giving that to a tenant. It's not done with any sort of metal orchestration at the moment. I think seeing the progress with SUSE virtualization and getting some ideas about where we take this next. But at the moment, this is just done with simple cloud init, roll out some images on a load of physical machines, build a custom cluster in Rancher, and go and install RK2 across all those nodes. So it's using, where we've got this, it's not using any network attached storage. It's using only local path storage, and that was just because generally the apps that we've chosen to put on here or advised tenants to put on here have been quite well designed. And we've got an S3 backend, for object storage for some of these big data use cases. But the good thing here is like kind of where we see this going is we're building up this kind of data platform offering where we can have a bare metal like in data ingest and processing. Those big workloads can sit on bare metal that require a lot of storage, and then we can have virtual clusters built off the same Rancher where we can run like whatever it'll be, AI jobs, Apache Spark or whatever it is that analysis jobs you need to run can kind of be run concurrently and alongside it, like in the same tenancy almost. The biggest we've got is 18 worker nodes in the bare metal clusters. It's not massive. It's like I said, it's single tenanted, so it's they're big machines. Like that's got they've got like 100 terabytes of NVMe each, and they've got 64 cores and a terabyte of RAM. So like they're big machines, but they're they're not super big clusters. We've not built this out to massive scale yet. We are going that way, but yeah, we're not there yet. Yeah, at the moment it's Elastic. Yeah, that's what's running on these. There's a few where, what is running in production at the moment is Elastic, but there's a few other data applications that we're looking at as well. But I think what we're trying to build essentially an open source platform to enable people to deploy an open source kind of data lake architecture, and figure out how we can best fit those needs. And actually, the combination of a bit of bare metal and a bit of virtualization seems to be kind of fitting the bill for that quite well. Possibly we're looking at combining that and having some KubeVirt running across these clusters as well. But at the moment, it's just the OpenStack virtualization. So a quick run through of how we actually deploy this stuff. So let's go back to what we do on OpenStack. So first thing we do, there's still a bit too much manual work involved in all this, to be honest, because spend a lot of time doing this stuff. But we go in, you create and configure all the relevant OpenStack stuff. So you create the projects, create the networks. That's done like through a portal. So we're kind of working on, integrating the APIs for that into our GitOps pipelines at the moment. Then we go and provision a 3-node RKE2 cluster in the platform project. So Terraform goes and builds 3 OpenStack VMs using the OpenStack API. Helm installs RKE2, and then Ansible deploys RKE2, and then Helm installs Rancher on top of that. We then use the Rancher 2 bootstrap provider to bootstrap the Rancher that's on there. So at that point, then we are into actually using Rancher things to go and deploy our clusters. We then create, so we're using the OpenStack node driver to actually deploy these clusters. We're not using cluster API here. So we're using the Rancher 2 machine config resource. So essentially that enables us to take the OpenStack projects and networks and everything we defined at the start, give that information to the resource, and it will understand then where those machine pools are, what the AZs are, and know where to build them. And then we're using the Rancher 2 node driver, passing in those tenant-specific details and going and rolling out that cluster on the OpenStack cloud. Some caveats with this approach, I suppose, is that we, at the moment, so with the Rancher node driver, can't provision multi-interface VMs. So that requires a bit of work afterwards. And also, like I said, this can't build on bare metal. So we're doing custom cluster. But there's still, like everything up to the Rancher 2 can still be used for those bits. We've just got some kind of workarounds for how we do the multi-interface VM deployments. We're on to, that's kind of an idea of what we've got, and kind of a lot of information, and I've covered, tried to cover everything without going into too much detail on any one part. But I think one of the things that's been interesting here is, especially this being in a telco cloud environment, is it's been tricky to get adoption of this, because even when people come with containerized workloads, they come generally with a vendor behind them saying, oh, just come and pay us loads of money and come and roll on our fully verified stack. And this is what we hear, they want a fully featured TSA compliant instance for a production ready application. There just isn't that dev platform adoption. There's no POC on our platform. People just turn up and want something that works straight away. I think, there's a few ways we've been trying to kind of mitigate against that. And, the use of Rancher has been one, in that it's kind of a familiar environment for people. So giving our application teams access to Rancher in sandbox environments and everything before a vendor ever comes along with application Helm charts to deploy has given us, at least familiarity within our SRE teams in the mobile space of what this environment looks like. Also starting to build expertise in the platform teams from managing a KVM-based OpenStack platform into the Kubernetes layer has also, I think becoming that center of excellence in our platform team on how to deploy Kubernetes workloads is helping, because actually a lot of the uncertainty from tenants a lot of the time we find comes from people just being unsure of what they're deploying. So if we can kind of be there to put a hand on their shoulder and say, well, actually, we know what's going on here. We know what your workload looks like, and we can meet it in these ways. And actually, the flexibility. So I kind of went through components, and I think where we're at is we've got something that seems to be meeting most of our use cases, but we're still very open to different CNIs, different storage requirements, different performance requirements, or whatever it may be that different vendors are bringing, and as much as we can, sticking within using open source tools to do that, and that's what's been good about how we can orchestrate this stuff with Rancher using the Rancher Terraform providers. We're able to just generally change some options around and give people what they want to try it out, and get off the ground really quickly and speed that up. So, Nelson.
Yeah, I just wanted to talk about the sort of platform adoption and sort of more platform engineering philosophy, right? Especially when it comes to adopting open source platforms, as well as people like BT and Fintan implementing platforms, and kind of what you need to be able to consider to be able to lead adoption, but also to be successful going forward. So I've put on here an ability bell curve, right? So as you've heard from Fintan, there are two kinds of users, right? Well, there's three kinds of users, right? So you've got, first of all, ClickOps-based users. So when you have vendors, like telco vendors, coming to you, say, we have developed a CNF application, they need somewhere to host it. Will those engineers care about what it's running on? No, they want it to run, and they need to ensure that it is a fully certified stack. Will they be maintaining it through through code or GitOps, anything like that. No, they need it to run and they need to be compliant. But then you also have within large telcos development teams who want to be able to develop and use platform engineering or cloud native tool sets like GitOps, right? And so you need to be able to support those users at the same time. As well as the point, which I put on here, ability, that admins don't have an ability, but that's not true. They have lots of ability, but they won't be nearly as involved in GitOps level, GitOps style application deployment, but they will be using the same kinds of tools to be able to actually, as we start to see people implementing CAPI, node drivers and everything else going forward and maintain that as code, you need to be able to support that maturity later on. So the really key piece here is as you start to you put in place platforms, especially cloud native platforms, you need to be able to suit all kinds of maturity within the cloud native skill set. So, and also support the maturing engineers, right? So be able to support the early adopters, but then also be able to fulfill later on development as well as adoption of more complicated and mature styles of cloud native tooling later on. At the bottom here, Fintan also covered this already around providing platform consistency, right? Being able to provide sandbox environments that is familiar to be able to encourage adoption, encourage use of a single platform. There's no point deploying a cloud native or CAS platform that is completely different to what's in production and then you need to edit it later on. So you need to keep it as consistent as possible to ensure that people aren't scared to use it or that people just really want to be able to use it going forward into production as well. So that's a bit more philosophy, but the really key piece here is I've put SUSE Rancher Prime enabling that because SUSE and Rancher is agnostic through infrastructure as well as using open standards, can support all of these different kinds of ability as well as platform consistency. Right? We can support basic ClickOps deployments or the more advanced Kubernetes native applications to be able to support high level ability as well. So that's kind of the idea that it's the platform that grows with your ability and with your maturity, not just one static one that you might need to re-platform later on in the time. Go ahead.
Yeah, and it's like I suppose it's like where we're looking at this. So bit of like the future kind of looking stuff now. It's quite small, but where we're at the moment is we have a platform now. It's on the OpenStack platform, but we have something. It's still, there's still a lot of manual work in building these and responding to tenant demands. I think because we're integrating with the OpenStack cloud that's there already. So the kind of next step we're looking to go is actually to turn that into a product. And that's, I think some of the ways we do that is, probably moving over to the use of Cluster API. We're in the process of doing that at the moment. There is a cluster. The reason we didn't do that actually when we started is because the Cluster API provider for OpenStack didn't really exist when we first started doing this. So once we had made some progress with the node driver, we just kind of kept going down that road because it does work. We're also going to expand our GitOps model and kind of ultimately look towards a kind of tenant self-service model so that tenants can come in, give us a YAML and get the cluster with the configurations they need. The kind of next step then is expanding the feature set. So I touched a little bit on eBPF and the load balancing stuff, but however we can enhance performance and enhance security. And I think one of the things I've found internally is that a really good way to get stuff done is if it helps your security posture, then normally people say yes and spend money on it. So it's a good way to sort of start to bring in these eBPF based CNIs and load balancers and everything because you do get so much more observability over your workloads. And I think this is probably the biggest point on there is like I said from the very start, this is on a platform that already existed, and it's a step in a journey towards us offering a containerization a CAS platform, a containerization platform for telco workloads. And there are only going to be more opportunities as we go forward. Right now, with the requirement to have 3G, 4G, 5G all in the same core on the same cloud, there are very, very few vendors who can provide those applications. And those vendors therefore can afford the luxury of being very, very opinionated about how they do things. As we go down the road and move towards 5G standalone or whatever is next in the future, there are going to be a lot more vendors who can provide us with applications to run on these containerization platforms. And I think the drive here is to be ready for that and to have a containerization platform that we can do that with. And we're looking to things like Silva, see what validated stacks are available. And obviously, what you've seen here doesn't quite follow what's in Silva and what SUSE are doing with Silva and with the operators in there. But actually, it's still, you can still take bits of that stack, and it helps us plan for the future and see where we're going. Yeah, anything to add, Nelson, to that bit? Cool. That is it then. Any questions? Thank you.